Continuing on in 9.2, we're going to start here with number 4, and now we're going to be using the sum and differences formulas for tangent. And again, this can be derived. It's placed in your textbook. There's a proof there. But for our sake, we're going to be looking at the identities we know they to be. So here is tangent of alpha plus beta, and here's tangent of alpha minus beta. You can see that it's entailing tangent alphas and tangent betas. And so our process, again, the same. Write the sum formula, substitute, simplify. And so what we want to do is we want to work with examples such as this. I want to find the exact value of tangent of pi over 6 plus pi over 4. So I'm going to utilize my sum formula from up here. So this is going to be equal to, this is my alpha, this is my beta. So this is going to be equal to tangent of pi over 6 plus tangent of pi over 4 all over 1 minus tangent of pi over 6 times tangent of pi over 4. Now executing out pi over 6 and pi over 4, you want to use your unit circle. Take your sine over your cosine, simplify. So I get values such as for tangent of pi over 6, let's write these up here. Tangent of pi over 6 is equal to 1 over square root of 3. And tangent of pi over 4 is equal to 1. Plugging in the values here. So I have 1 over square root of 3 plus 1. 1 from my formula minus tangent of pi over 6, which is 1 over square root of 3. Tangent of pi over 4 is just 1. So I'm going to go ahead and combine these two together. When I combine my top, I get 1 plus the square root of 3 over square root of 3. When I combine my bottoms together, I get square root of 3 minus 1 all over square root of 3. Dividing these fractions and simplifying gives me 1 plus the square root of 3, square root of 3 minus 1. So you can see that the difficulty in these identities doesn't really necessarily come with plugging in the identity, but sometimes it's going to be in the details that you might get lost. But again, the sine, cosine, and tangent sum and difference identities, the steps follow suit. Write your formula, substitute your values, use your trig circle, and simplify. So for part 5, what I want to do is I want to roll in and kind of have some conversation about what's going on with number 5 here. First of all, let's recall from section 7.2 where we worked with our right triangles and we had the conversation of if the sum of the two positive angles is pi over 2, that they are complements. So moreover, let's say the sum of the two acute angles in a right triangle are equal to pi over 2 because the third angle is a right angle. So they are also complements. So this figure could come out of this. So if I'm thinking about sine of theta, it would be equal to cosine of pi over 2 minus theta, because these two together total pi over 2. So if I want to figure out sine of theta, it could be related as cosine of pi over 2 minus theta. Thus, when two angles are complementary, we can say that the sine of the angle equals the cofunction of the complement angle. So we pick up this word cofunction and we pick up this value here. Similarly, tangent and cotangent are cofunctions, and secant and cosecant are functions, or cofunctions, excuse me. And so what I wanted to do was show you a little bit of this information because as we go into this, you're going to see this idea of cofunction identities. And so I want you to understand a little bit of where they're getting this from. So you see your sine, cosine. You can see there's tangent, cotangent, secant, cosecant. You can see that we've reversed them over and looked at the cosine and the sine, and it all goes back to those complementary angles and the right angles. Now the good news is with this is that you can manipulate, make a little side note here, as needed. And you're going to do that by using the above lectures, previous pages of these notes of our sum and difference identities. And so you could see if I wanted to look at, say, cosine of, I could use alpha minus beta to consider cosine of pi over 2 minus theta. There's my alpha, there's my beta. So this would give me cosine of pi over 2, cosine of theta, plus sine of pi over 2, sine of theta. cosine of pi over 2, that's trig circle 0, cosine theta, plus sine of pi over 2, that's trig circle again, and that's 1, sine theta, yielding me with sine theta. So you can see how I started with this cofunction and it led me to sine theta by proof of my difference function of cosines. Now let's jump down here into an example and see what it says. It says write in terms of its cofunction. So I want to turn tangent of pi over 9 into its cofunction. So I'm going to use this identity up here. Tangent of theta is equal to cotangent of pi over 2 minus theta. And so I'm going to work through this. I know that tangent of theta is equal to cotangent of pi over 2 minus theta. So if I'm looking at tangent of pi over 9, that would be cotangent of pi over 2 minus pi over 9, just replacing these thetas with the same value. Adding these fractions together, I need common denominators, so let's call that 9 pi over 18 and 2 pi over 18. Adding them together, or subtracting, gives me 7 pi over 18. So write in terms of the cofunction, I was able to write in terms of its cofunction, cotangent. And so these cofunction identities are going to come in handy as we're working through some of these problems. Now for part 6, we're going to be using our sum and difference formulas to really work with a broad sense and verify some identities along the way. So I want to look at this gray box here, and it says given an identity, verify using sum and difference formulas. And so let's note some of the things it says. Begin with the expression on the side of the equal sign that appears most complicated. This is the conversation we had in section 1. Rewrite that expression until it matches the other side of the equal sign. That's 9-1. Occasionally, we might have to alter both sides, but working on only one side is most efficient. Part 2, look for opportunities to use your sum and difference formulas. 3, rewrite sum and differences of quotients as single quotients. And then step 4, if the process becomes cumbersome, rewrite the expression in terms of sines and cosines, which is we've had this conversation as well. So I want to work a couple examples for you here. It says verify the identity. So what I'm going to do, similar to 9-1, is I'm going to start on this side. 1, it looks a little bit more complicated, and 2, I know the identities for these. So for sine of alpha plus beta, I'm going to say sine alpha cosine beta plus cosine alpha sine beta. So that is this first identity here. Plus, now I'm going to plug in my next one. Sine alpha cosine beta minus cosine alpha sine beta. And again, that's this part. Now, if I start cleaning this up, you'll note that I have similar terms here. So I could say 2 sine alpha cosine beta. And that these terms cancel, leaving me with just this term, which is what I was aiming for. Number 2 says verify the identity. So again, I'm going to start with this side. It looks a little bit more complicated. And I know an identity for that top part, so I'm going to start there. So I'm going to plug in the identity for the difference of these sine functions, which would be sine alpha cosine beta minus cosine alpha sine beta. All over, I'm just going to put the denominator. Cosine alpha cosine beta. Now that's equal to, let's think about this. I'm going to split them up. So I'm going to do this term over the denominator, sine alpha cosine beta over cosine alpha cosine beta, minus I'm going to do this term over my denominator, cosine alpha sine beta over cosine alpha cosine beta. So I've just split this subtraction here, or this fraction up. Now consider this. Cosine beta over cosine beta would cancel, and cosine alpha over cosine alpha would cancel, leaving you with sine over cosine, which is tangent alpha, sine over cosine, which is tangent beta, which is the result I was trying to get. Now, as you're working through all of this section, here's the page that's going to be handy to you as you work your homework. Here is a summary of all that we have accomplished in 9.2. You can see you have your sum and difference formulas for cosine, sine, and tangent, and then you have your cofunction identities as well. So I would use this page as well as your unit circle in completion of the problems that go along with 9.2. Let me know if you have any questions along the way.